let's say your school is interested in finding out how many languages their students can speak. As it turns out, from your class, 4 people only know 1 language, 9 are bilingual, 6 students are trilingual, and whoa. Let's stop right there. This is getting out of hand, isn't it? Organizing all that data would probably make anyone pull their hair out. Well, when faced with such a situation, you can always rely on a frequency distribution table to help you organize data pretty easily. Previously, we learned how to arrange such raw or ungrouped data into a tabular form like this, with each observation considered as a group noted alongside with its frequency. We saw that a frequency distribution table has 2 main columns. The first column lists all the various outcomes that occurred in the data, and the second column lists the frequency, that is, how many times the observation is repeated. So, putting any ungrouped data into a table helps make it simpler to understand and analyze. Besides that, we also saw how we can shorten or summarize this table further by converting the observations into the groups of certain ranges. This kind of grouping is considered when dealing with discrete observations, whereas this grouping is considered when dealing with continuous observations. In this video, we're going to learn how to convert an ungrouped data into a discrete frequency distribution. Let's get started. According to the given question, 5 coins are tossed 20 times in total, and the number of heads recorded at each toss jotted down. The results obtained corresponding to every toss is shown on the screen. Now, to convert this ungrouped data to a discrete frequency table, the first step is to find the minimum and maximum values in this data, and then write the whole data in ascending order from minimum value to the maximum while ignoring the repetitions. This becomes the first column of our discrete frequency distribution table, labeled as X, since the values of observations are variable. Great! We'll now go ahead and record the occurrence of each observation using vertical bars, known as tally marks. For every time an observation occurs, we'll draw a bar. Since 1 occurs thrice, we'll draw 3 bars. Get it? Similarly, count the occurrence of 2. 1, 2, 3, 4. Now pause. The 5th bar would always be made horizontally or diagonally across the other 4 bars, like this. And continue. 6, 7, and 8. Time for the 3rd observation. Count it with me. 1, 2, 3, 4, and 5. 5th bar being diagonal as always. Do the same for the 4th and 5th observation as well. That concludes the second step of making a discrete frequency distribution table. Our final step is to draw a frequency column, which is just the numerical representation of the tally marks. Simply count the tally marks and write the result in the frequency column. Here we have 3. Here comes 5 plus 3 equals 8, and so on. Well done! This is how you get a discrete frequency distribution from a raw or ungrouped data. Now, remember that the sum of all frequencies represents the total number of our observations. We show the sum by using this symbol of summation, or what we call the sigma. I don't know about you, but for me, a discrete frequency distribution makes reading data in a sentence format much easier. Then, what about continuous frequency distribution? Guess you'll have to join in the next video to find out. Stay tuned.